Okay, so I end the poll now. So let me share with you what is here. Um, as you can see, about 94 of you say you have laptops, and 63 say you don't have laptops. Um, so what I would do is those of you that do not have laptops, um, all right, I'll figure out something. I'll figure out something. That's if you can get laptops from your friends, so we can bring it to lectures, to places where we don't have um, computers in there, you can bring it along so that we can have our practical section, possibly from next week. All right, so I'm stopping the poll and let's start with today's activity. All right, thank you very much for your answers. So I think we started last week. Unfortunately, the light went off. I'm hoping it stays this time around. I'm Felix Labi Aye. I'm going to hold the lecture for the Intro to Computing. Over the years, I've been teaching the mining students, and I hope to. And so far, I think it was quite recent that just about few people failed in my class. Nobody has ever failed in Intro to Computing. But I think as of last year, about 5 people failed. Very, it was a shock to me actually, because I know most people get an A in this particular. So please, I would want to take this opportunity to entreat you, at least try your best to read out any handout that I give you, assignment that I give you, make sure you go through that. And come for your quizzes. If you don't write quizzes, you know it's also might also go against you. All right, so generally for every chapter, there are objectives that you'll be talked through. But in general, the course, for this particular course, you will learn, there are some few things that you're going to learn. Learn the basic uses of computer, what computer is, and what hardware is, some of the peripherals that are part of the computer hardware. And the good thing is we will also train you how to use the Microsoft Office suite. Microsoft Office suite comes with Word, Excel, PowerPoint, and sometimes Access. Only for the introduction to computing, we don't teach Access. Access is a database environment where you can create databases and all. But what we normally teach is Word, PowerPoint, and Excel. So I'll quickly move through this because I believe we talked about it last time. Most of the lectures is going to be on, I'll have some of the lectures being on VLE. So for instance, lectures like this, that is, me teaching you some few things, I would hold them on the VLE. And for some time now, as you are aware, we've had some clashes. And apart from that, availability of room to also teach you has also been a problem. Over the years, what I've been doing is during our lecture periods, I hold a VLE session for all of you. So in that case, I expect to have all the class members in there. Now, unfortunately, by the timetable, I have 2 hours with you, 2 hours with you, 2 hours with you before this 1 hour or 2 hours. But that is not meant for me to teach you, to lecture you as is happening today. That is meant for practicals. And because I've not met you, that is why I've not been able to hit you up on that. So then we will have some tutorial sections. We'll have some practical labs. Most of the activities that we're going to handle in here, I'll give you a handout. The first PowerPoint that you see right now, I'll give it to you. I'll put it up on the VLE so you can see it. The video that I'm recording currently, I'll also put it up on the VLE. So most of you can also visit and also read and revisit what I talked about some time back if you want to recap any of the things that I said. As I said, the VLE is going to hold most of the contents for this particular course. If you need help, these are places These are ways you can get in touch with me. I'm at the, sorry, my office has changed right now. I'm at the School of Petroleum, office number 5. And this is my research area. Unfortunately, I'm not a computer science student, so I don't know how I can be of help to you. But of course, I've had some students who are not computer science students, but they wanted to learn things relating to computing, programming and stuff, and they got in touch, and some are doing very well, irrespective of them not being computer science students. I think I'll take this opportunity to also advise you. You are mining students, it would be nice for a mining student to learn programming or be savvy in things relating to computer. Why do I say this? At the end of your four-year stay on campus, you have your BSc mining engineering, which is your certificate. So on your CV, if you have things that relates to, you've learned some extra things, maybe in the area of computer programming, and that also boosts your CV. And usually I advise students to do that during the long vacation when they are not on internship. The good thing is learning programming, you can just go to YouTube and you see tons and tons of videos online that can teach you some of these. Excuse me. And of course, in your final year projects, I don't know the topic that some of you will pick. If you have programming like Python associated with some of the things that's your final year projects, that's even enhance your project. And I've seen lecturers with Ph.D. Putting in using Python and other things to come out with something beautiful in the area of mining and also related disciplines. So programming should be one of the things that you should learn at your leisure if you have time. I will show you the TA when we get to the class for practicals. There's one more thing that I also would want to talk to you about. Let me bring out a laser so I can be pointing out some of these. Excuse me. Now, LinkedIn is a very powerful environment that I would advise most of you would. If you don't have a LinkedIn account, please create a LinkedIn account. Your experiences, the things you learn, your internship, and things that you learn as during your stay on campus, you can showcase some of those things online. LinkedIn is mainly for professionals, It's not a place where mainly you put in your pictures, your videos. No. They mean business. So people will get jobs through LinkedIn. So you have 4 years to build your profile in LinkedIn. So advise, at least create a LinkedIn account, associate yourself with some other people, learn from them. And by the time you are out of UMAT, you'll be surprised the number of connections that you have on LinkedIn. And that connection can probably give you a job. You never know. So start early. You start early, you're able to probably be successful in that area. All right, so let me move on. So attendance, 10 marks. Usually I give almost every student 10 marks unless you really don't come to class. Continuous assessment is going to be in this way, 30 marks. So the total of these two make 40, which is the CA, that is a continuous assessment. So the exams is usually 60%. And for the continuous assessment, I'm going to give you individual presentations. And you also would have group presentations. By group presentation, I mean, when we treat PowerPoint, you'll be put in groups, and each group would have a talk with us, will teach us what they've learned. The topic will be given, have all those topics from the VLE. I've hidden all of them. I'll show them to you as and when is deemed necessary. So I expect you to, at this point, try and see people that you can mingle with. If I don't do the grouping myself, I'll tell you, look out for a group of maybe 5 or 10 people, and these are your topics. Go through it, come and do a presentation. So you will have a group presentation too as well. Most of the lab practicals will be done at the lab. The exams that we normally hold is most of the time MCQs. There's one more thing I would want to talk to you about. This especially, this assessment, you would have a quiz. Most of the time, there's a within the middle of the semester, we give a quiz where students will answer multiple choice question, which we term as MCQ, others will say section A, or A, B, C, D kind of question, a selection of those, and sometimes some few feelings. But please, that is about the continuous assessment we have in there. Now, let me start with what a computer is. I think most of you already have an idea what it is. I would want just two people to just tell me what they think a computer is. If you want to answer, just raise your hand. I'll give you the chance to talk. Then you talk. You can have your hands raised. Just tell me what you think a computer is in your own mind. Just two people. Yes, quickly. All right, let's have Eugene. Eugene, you can unmute yourself and talk. Yes.
Please, a computer is an electronic device that processes data into a meaningful.
Can you come again? I think we lost you along the line.
A computer is an electronic device that processes data into a meaningful information.
Well, that's great. There are some few other things that we probably might also hit on. Yes, can we have the second person? Thank you. Thank you, Adrian. Okay, let's have Obadiah. Is it Obadiah? Anthony.
Obadiah Anthony. Yes, sir. A computer is a device that accepts information and converts it into data, which is raw, the data that computer understands, and also brings it back to human language, information that humans understand. That is the input, output, and also stores information.
That is great. That is very great. But both of you are not so wrong. That is great. Let's have the last one before I hit on the. Yes, can you, Yvonne? Hey, let's have our lady, Yvonne.
Okay, a computer is an electronic device that accepts data, processes it into a meaningful form, that is information, and then stores it.
That is wonderful. In fact, that is great. All these definitions are right, but there are some key words that I will talk about. I think Yvonne made mention of most of them. So I will hit you on that and we can continue. So I'm going to mute you, Yvonne. I can see, Francis, all of you have your hands up, which is great. The class is supposed to be interactive, so don't worry. In the meantime, I would say let's put our hands down. So as we move along, there will be more questions that I'll be asking and you can answer along the line. That is so great. Thank you for that. Yeah, so moving on. So generally, anytime you think of what a computer is, I'm believing most of you did ICT. Oh, okay, you're not computer science people, so you probably didn't do ICT in school. Yeah, so anytime you talk about a computer, there are some key things that you should have in mind. The first thing is this one. It has to be electronic. So when you say something is electronic, it means there is some sort of energy or power that is given to it, more like electricity. So first of all, a computer should be an electronic device that operates under some sort of instruction. The instructions most of the time is what we term as a software. Before a computer can work, you need something we call possibly an operating system. Sometimes it's a software. I'll explain those differences to you. And the moment is able to, based on the instructions that is given to the computer, it will be able to store the information in somewhat memory, something more like a memory. And then it also accepts input, manipulates that input that is given it, and finally to produce information. So generally, if you are asked to define what a computer is, then what our dear lady talked about, an electronic device that accepts inputs from a user, processes that input, and at the end of the day, spew out an output. And finally, it can also find a way to save data also in memory. So an electronic device which is capable of receiving data in a particular form and perform a sequence of operation on it to produce a result in the form of information of signal. So it depends on whatever it is. Sometimes it could be signal, sometimes it could be information. So first of any time you're asked to define a computer, you should always make mention of it being an electronic device. You should make mention of it being able to accept data from a user or input, it being able to process that input that was given to it, and it being able to give out some information and something out based on the information that it processed. And sometimes at the end of the day, it finds ways to also store the information also on your computer. So the electronic aspect is very key. All of you are right, but have all those basic keywords in place. In the exam, we hardly ask students what a computer is. I don't remember in any of my exam questions that says, what is a computer? No. Usually put in the question is asked in a way that we want to find out how you understand what it is. Now, most computers that you know, to finish this slide today, about 78 slides, I'll be very fast. Most computers that we have today are limited to 4 mathematical operations, and these operations are the addition, 4 mathematical operations and 3 comparison operations. The mathematical operations are the addition, subtraction, multiplication, and division. By comparison operations, these are whether, for instance, whatever we are dealing with, are these 2 things the same? Is it equal to each other? Is one greater than the other? And is one less than the other? That is the comparison operations. So computers usually work using these 4 mathematical operations and 3 comparison operations to be able to come out with information. Now, there has been some sort of evolution of the computer. But unfortunately, I'm going to hit on on some of these. In the handouts, you have the chance to read extensively on those, on the history or the evolution of the computer. So I would activate the handouts today. All of you will have access to it, so don't worry. But you can read more. Now, some time back, usually when we talk about the evolution of computer, how did computer really come to be? Based on how it was some years back and how it is now. So it started using some years back. Computer weren't really there, but the act of counting stones and other channels were visible. So that is how people got to know that, okay, we can find a way to do some kind of computations using these 4 mathematical operations and also the comparison. So that is how it's really evolved. So it started by using counting of stones, maybe comparing stones and other things. So along the line, we had a precursor of the abacus, that which is an accounting instrument, was invented by the Babylonians. So along the line, they were using stones to count, to do some sort of basic computations. Then the abacus came to be. And the abacus was developed by the Babylonians. It was invented by them. Those that have not seen the abacus, I think there's a picture here which I'll show you. And those that I think they're now, is it UCLA math or something? I think there's some sort of math that you see students give them the numbers and the type of operators, and they'll be counting in, with their imaginations. Most times they start with the counting with the abacus, and they have a strategy of, doing these computations as fast as possible. So somewhere in the 1971 through to 1791 through to 1871, Charles Babbage was present, and he designed 2 computing machines. And the first one was the difference engine, and the second was the analytic engine. As the name says, difference engine. So what it was responsible was to solve polynomial equations. You know what polynomials are? By the method of difference. So if there is a polynomial equation that is given, you use a method of difference. The difference has got to do with, finding the difference between probably 2 numbers or whatever. He built this difference engine to help in the computation of polynomial equations. Then along the line came also the analytical engine, which was general purpose computing device. So during his time, that is when these came to existence. So irrespective of all these, their designs gave the basic form of our modern day computer. Irrespective of all these, most of the modern day computer got to be built based on some of the difference engine and also analytic engine. And by now, you are aware that we have some devices that we term as input devices, others as output devices. We also have the preprocessor and the storage devices. So their design came based on these already existing manual kind of computing machines. Those that have not seen the Abacus before, this is how it looks like. So the difference engine has been considered by many to be the direct forerunner of the modern day computer. But that was the one that was invented first. And this device did not have a memory. So how was the computation done? And what Charles Babbage later designed was the analytic engine. Because it didn't have memory, everything was done manually. So the computation was also done manually. There was nothing really electronic when it comes to that. In our current world, now when we say a computer, there should be some sort of an electronic, something electronic that makes it more of a computer. But before, most of the things that's what we classified as a computer were not electronic. All right, so that is how the difference machine, how the Abacus looks like, and the difference machine also looks like. But the evolution, there is more information that is in the handout, and you can read. So let's start with the first generation type computers that were built and also used. These types of computers were very slow, they were inefficient, and they were very expensive. As we move along, you get to realize that some years back, there were computers, things that we classify as computers were not owned by individuals like we own computers now. So when we talk of the generations, a lot has really happened. When any time that you hear the word generation, most of the time it refers to the Intel Core series, which is the CPUs. And Intel is the one that released the new CPUs with the term generations on a regular cycles. So each of these generations also has a name and a market's name. We'll talk about each of them as we move along. There were times we had the Pentiums and the rest. So for the first generation computers, they were mostly built with the vacuum tube. I'm sure most of you are aware of your cathode ray tube in your chemistry class, how electron beams are fired from an electron gun to the surface of the screen that has the phosphorus coating on it. So that is how the first generation computers were. They were mostly built on the vacuum tubes, the punch-down cards, and the machine languages. So you have the chance to read on all these when you have the handouts in there. Now, on the second generation computers, what was more prevalent was the transistors. And most of these were low-level languages. The third generation computers use what we call the integrated circuits, that is the ICs. compilers and were of higher level language. That is when higher level language were used to process to help in the computation of some of the things that we want to do. In our modern day, we normally say we are on the 4th generation computers, and what we normally use is somewhat somehow sophisticated. And these are electronic gadgets, and most of these have what we call the microchips. And most of these microchips was first invented by Intel somewhere in the 1971. The 5th generation computers will work under AI. So now things are really happening. And I don't know if any of you have heard of ChatGPT. And apart from that, there are other AIs that are doing wonderful. Those that are on TikTok, you realize that there are some AIs that are able to even create an avatar or some sort of an art picture of you. Based on your picture, is able to process it to come out of it. And some of these AIs are also able to come out with how you would look if you were probably an Indian or a British or probably maybe a South African or a South American. You know, all those people, some of these AI are able to, predict and let you know how you would look like if you were from different countries and the rest. Now, you should be mindful that most of the major manufacturers of our modern day computers are these people, the IBMs, the Hewlett-Packard, that is the HP. And those of you that have laptops, you can do it and see if you can see your laptop, your laptop name in here. If you don't, that does not mean your laptop is not a good one. It is a good one. But the major manufacturers that came to light in the production of computers were based on these people. Now, the word computer came from the Latin word computare or computere, and the idea is to reckon or to sum up. So, by definition, from the Webster definition, a computer as any programmable electronic device that can store, retrieve, and process data. Of course, if you are asked to define a computer, I don't expect you to use this. But based on what has been said in previous slides, those ones are the ones that we expect you to use. So the Abacus, which was somewhere 3000 before Christ, that is how it looks like. A simple counting aid, likely invented. It's believed to have been invented by. So I'm sure some of you have seen it. Even now, the Abacus, what we see now is a little variation, a little how it looked like years back. Okay, so the generations. These slides. I'm going to give you. I would want you to read those ones, so you can have an in-depth on each of the generation computers. The history of the computers based on the generation. So I'll give these ones. I was telling you earlier on that those times, the ones that were built, they were very big. And most of the things that were happening were more or less manual. So you can see how big these were. So this is supposed to do some sort of computation. So we have in here the ionic computer, which was invented somewhere in 1955. And it was stationed at the Pennsylvania State University. You see how big it is, and you can imagine the kind of computation how long it would take to even come out with a computation. Now, in a modern time, if you should even tell an AI to do some sort of computation, in a modern to do some sort of computation, you realize that the computation will be done very fast. But during these times, most of the things that were happening would take some time. It would even take days for the computation to even happen. Those that have also used ChatGPT, if you are even able to give it, that is an AI. ChatGPT is an AI. You can give it a polynomial equation or possibly an equation and tell it to solve for maybe a variable or whatever. And within a split of a second, the answer does come. So you see how fast it is, how AI is, are really enhancing our way of life. But those times, the same equation, if it's given to this computer, the INI computer here, it takes days for it to finish up the computation. All right, and of course, they were very big. You can see a whole room was used to store or to store some of these huge computers. So as you realize, when I talked about the fourth generation, that is when the microprocessors get come in. So see how the microprocessor really look like. These are chips that are embedded on the computers. So this is how the first laptop looked like. And those of you who have seen the 5 1/4 floppy disks, I don't know if any of you have seen it. It's a floppy. I don't know if any of you have even seen a floppy disk before. Yeah, because I'm sure most of your time is only pen drives that are available. I used to, I remember back in the days in school when you are given assignments, you have to save it on a floppy disk, and the maximum size that a floppy disk can hold, that was a 3.5 floppy disk, was 1.44 megabytes. I mean megabytes. I didn't say kilobyte. Sorry, gigabytes. 1.44 megabytes. So that should tell you how small it is. But now the least pen drive is probably maybe 1 gig. So you can imagine the number of megabytes that can fall within a gig. And even now, most people don't use pen drives. Hardly will you see a 1 gig pen drive. Usually 16 gig and so forth. So that is how the Osborne 1, which is the first laptop, looked like. From here, you can see the screen. See how the screen is. And most of the things that were happening here were, I'll talk about it, we call it command line. It didn't have what we call how the interface are, the graphics look so beautiful and the rest, no. Everything was more of a command line. The black screen with, information put in there. And that is how the keyboard is. Yes, so, and it weighed about 24 pounds. It was a little quite heavy. In our current world, this is how today computers look like. And these are some of the extensions for some of them. This is how the CD-ROM and the rest, PDA. I don't think people use personal digital assistants now, PDA, because of the introduction of phones and the rest. So these are laptops and also electronic tablets and the rest. We believe that some time to come, the world is going to look more like this, where those that have used the VR headset before, when you wear it and you are probably in a game, the environment, your real environment changes to a different environment. And your actions, you act like your new environment. And you leave some time to come, that is how things are. Computers are really going to advance, even go beyond what I just talked about. So there is more to that. Yeah, so day in, day out, new things are coming, new technologies are coming. We believe some time to come, we might not even, or there might be some time to come where by the press of a button, maybe a whole building can collapse and be boxed into something small. And the press of a button again, maybe a whole building can come out. Anything is possible when it comes to the field of, computing. All right, so generally, devices that usually make up the computer systems are the ones that we see in here. This is just a general overview, but we will talk about them, glass and other things. Most of these we will talk about. So for a personal computer, we have the monitor, external speakers, the keyboards, the mouse, and the system unit. So if somebody says, oh, I have a personal computer, these are some of the key things that a computer should have. And within the system units, these are the things that we have in there. The TAs will show you some of these hardware in the computer. So that's the power supply. So within this, there's a power supply that to the component that resides inside system units. The microprocessors that are in there, there's the hard disks and the rest. All these, we have some old computers that we use to showcase and let you know or have an idea of these. So don't worry. So generally, the term is used to describe a collection of devices that function together as a system. Now, for a computer system, there are some key things that usually play. So this is a computer system. Based on this, the computer system is made up of three main things: the hardware, the software. The software and firmware sometimes, based on the type of computer that is being used, we normally sometimes we interchange it. But if we're dealing with computers, then a computer system would have a hardware, a software, and a firmware. Now, the software is made up of what we call the system software and also the application software. I will talk about each one of them, so don't worry as we move along. Now, the application software relates to software that are being developed to do specific things. I'll explain all those things as we move along. So they are already made applications, and they are tailored to perform specific functions. For the system software, usually these are the things that we normally talk about. That is the operating system and the network operating system and the drivers. So these, anytime you talk about a software, it is made up of these: the system software, application software. So these are different types. We'll talk about them. For the firmware is made up of the ROM, the BIOS, and the post. So now, most times when we talk of the BIOS, I'm sure some of you know my BIOS is messed up. I'm unable to boot my computer. The BIOS is an acronym for Basic Input-Output System. So BIOS stands for Basic Input-Output System. Now, as we move along, there are certain things or certain acronyms that you should have in mind. Most of the time during an exam or quizzes, some of these acronyms, we keep mentioning them. We keep mentioning them, or we ask questions about them. So for instance, in an exam or a quiz, if I ask you, what does BIOS stand for? You should be able to tell me that it stands for a Basic Input-Output System. And what does the BIOS do? And the BIOS includes instructions on how to load basic computer hardware. And most of the time, it also includes a test, which is referred to as the POST, which is the POST stands for Power On Self Test. So when you boot the computer, it goes through some sort of self-test, make sure things are in place. And these are all embedded and included inside the BIOS. So the BIOS also include what is referred as the POST, which will ensure that the computer meets all the requirements before it boots up. When you say booting has got to do with powering of the computer. There are other things that we talk about. So when you say POST, that is the power on self-test. Now, on the left side, that is where the hardware resides. So the hardware, things that are tangible, anything that you can touch. And these are all things that you can touch when it relates to a computer. All right, so that is about a computer system. And still on that, there are some two key components that you'd always have in mind. So all computer systems consist of two main components: the machine components and the program components. The machine components are the ones we normally term as the computer hardware. And the program components is also what we term as the computer software. Now, based on these two, we can now talk about the machine components, which is the computer hardware. And with that said, anytime you hear of a computer hardware, you should have in mind that there are internal and also external physicals that are tangible parts of the computer system. By it being tangible, it means you can touch them. So anything that, for a computer system, anything that you can touch is a computer hardware. So that is the hard body mass of the computer. If it relates to humans, for instance, my entire being, I'm the hardware of the person Felix Labiaye. And within me, I have, maybe somebody will say, a soul or a spirit. So the soul more or less will serve as my software. And the soul is something that you can't touch. You can't touch it, but you can touch my body. Because you're able to touch my body, it becomes the hardware. So in the same vein, when you talk of computer hardware, anything that you can touch when you see a computer is a computer hardware. So these are internal and external physical. So these tangible parts could be external. It could also be inside the computer itself. So that is what makes it a computer hardware. So the internal hardware is located within the main box, which is written as the system unit of the computer. And external hardware is located outside the system unit and plugged into a connector, which we normally term as ports. So the external hardware are the ones that we normally see around. And these, most of the time, we connect to them. So for instance, if you want to use maybe your mouse, you can use a USB connect to it. That is the external hardware. So the computer hardware also refers to all the mechanical and electronic components of the computer system and its accessories. The main role of a computer hardware is to do the computation of stuff. Now, looking at how a computer looks like, these are the ones you see in here are the computer hardware. So we have in here, I see some people writing things. I don't really get it. All right, so what we have in here, so this is the computer itself. The computer is made up of a monitor, a system unit, the keyboard, and all these. So the ones that are connected to the system units. So the system unit itself is a hardware. And we have all these devices connected to it. And these are also hardware. They are all physical hardware. Now within the system units, we have a RAM. So the RAM is an external computer hardware, an internal computer hardware because it is found inside the computer. So we have the speakers, as you can see here, there's the speaker. This is the microphone, as has been labeled over here. Now, also from here, you can see this is the hard disk itself, normally termed as HDD. So a hard disk also looks like this. And within it, we have a plate, which is very shiny. Many of you have opened a hard disk before. I don't know if there is any available. I'll talk to the team. Inside the hard disk, there is a very shiny magnetic component in there that is able to store data in there. So we have these devices now reading information from this magnetic field, magnetic device components in here of the hard disk. That's how information is stored on the hard disk and also retrieved. So the hard disks for a system unit, the hard disks, the memory, and some other things are all found inside. So those are internal computer hardware. These are also examples of internal computer hardware. So the memory, the power supply, all these that we can touch, but they inside the computer are what is termed as internal computer hardware. Now, this is how the motherboard looks like. You can see we have in here a portion where the CPU resides. We normally say the brain of the computer is a CPU. There are some specific questions that I'll ask some time to come. So please pay attention a little bit over here. You can see the CPU is here. That is where this particular CPU is AMD. So we'll fix it in here. And we have the fan that is going to reside on top of the CPU. There's a reason for all of that. I'm sure I will talk to you about it. Now, what are some of the things that the computer can do? So the computer can perform 4 general operations, which comprises of the information processing cycle. Now, the component that you saw on the previous slide, the components, I mean, the component that you saw that give information to the computer for computations and also bring out information can be classified into these 4 general devices. We have the input device, and as the name says, input device. So it is a device which is used to input data into the computer. An example could be the keyboard. There are other examples that I'm going to show you. We have the processing device. And what the processing device does is to perform some sort of calculations and also comparison whenever it is necessary to do that. Someone is asking if the video card is the same as the graphic card. Yes. In a way, you can say yes. The VGA, the video card can also be taken as a graphic card. Yes. Now, an output device presents the results to the user. Output device. An example could be the printer. You know, when you type your Word documents and you want to print, there's a device called a printer that can help you have a hand what you've done. We also have the storage devices, where we can have primary and secondary storage devices in there. No worry, we'll hit or talk about each one of them. This is a general overview of most. So that is the storage. When you talk of storage devices, we have the primary and the secondary. And as the name says, they are storage devices. So they store information, data. And we have communication devices. And what it does is to allow the user to also communicate others and also access remote information. We use that a lot. So these are examples of the inputs. Those were the examples of the input devices and the output devices that I just mentioned. Now, how does this operation work when you talk about the input and process? And that is how it works. So we have the input device helping us to put information into the computer. And once the information is inside the computer, that information, in this case, let me use data because data is a process information and information is a process data. So this is the steps that is going through to be able to come out with this. So the input devices help us to put information into the computer, and based on the processing, the things that could be done, the data could be processed. The processing, we either store that data. So for instance, if you are developing a software, because you are using a computer, you develop the software, all those processing happens inside the computer. You store a copy of it on your computer. So that is one way. When the processing is done and we get information, we can store it or we can output it. That is when the output devices come into play. So data and information I'm sure by now most of you know the difference between data and information. Data is unprocessed, do I say information? So anytime you have data being processed, it comes out as information. And of course, an information at a particular point could serve as data for another operation. So the fact that you've been able to process data to get information does not mean that information that you have is information throughout. It could be served as data. An example could be, for instance, when you guys fill the form online to, you applied online to UMAT, what we got from you were your records, your students' records, so all those information, all those things that you fed into the computer at the time, they served as data. We were just getting that data from you. Now, when you were done inputting in that data through your computer, that data comes onto a server which is located at the ICT unit. So that server now stores your data. So during the admission process, the software has been developed to get data from the user, which you have done. Now the admissions people will now contact me to say, okay, please go through the system and let us know and find out and pull out the data that will serve as information for us to use to give admissions to people. So now what I will do is to go onto the system, and now the data that you have given us, I'll pull out all your reference number with your grades and your name and all of that into an Excel sheet. So every row of the Excel sheet will be for one person. So if Derek J, for instance, would have one row with all his records, his reference number, I'll pick his reference number, I'll pick his surname, I'll pick his other names, I'll pick his gender, he's a male, I'll pick his first choice program, I'll pick his second choice program, third choice program, fourth choice program. Then I'll pick each of his electives. So the core subjects, the aggregates or the grade that he had for the core subjects and the grade that he had for the other subjects, electives, then the school he attended and the rest. So for each role, I will have, if there are 5,000 students applying, so I have records of 5,000 students all completed. By the time you filled, it was data. Now I am now putting this together in a form of what you call processing it in a way that will become an information for the admission committee. So when they pick up this Excel sheets, they have records of everybody and the aggregate that they had. So at that particular point, you served as the data. I provided the information. I processed the information using the computer, gave it to the admissions office. So it's now information to the admissions office. Once the admissions office have this information is something that is meaningful to them. So it is based on that they are able to sift through and say, oh, Prosper Foley, you have mining. You have been admitted into the mining engineering department. So at that point, my information, which is good for them, during the selection process, will serve as data for them. It was an information for them from the beginning, but when they are making their selection in the processing stage, it serves my information given them becomes data for them. So now they are also processing and picking up the best people that have maybe best. So at that point, my information is data. Then when they make their selection and come out with, if they are 5,000 and probably they've selected 2,000, they will send that information to me, which is now information which we can put into a system for you to now go online and print your admission letter because you have admission. So at any point in time, an information can serve as data based on what it's being used for. So you should have that in mind. So all computer processing requires data, which is a collection of raw facts, figures, symbols, such as numbers, words, images, videos, sounds given to the computer during the input phase. I'm talking to you right now. So what I'm giving to you, what I'm providing is more like sound. And you can see my screen. So you can see me, my screen, which is more of a video, which is a good thing. So it could be data at a point, it could be information at another point. So computer manipulate data to create information. Information is data that is organized, which is meaningful, and which is also useful. So during the output phase, the information that has been created put into the same form, such as a printed report. So an example could be during the your registration process, you logged on to the portal, all the courses that you were to take for the semester, you registered those courses. At the time that you saw those courses, they were data. When you registered it, you processed it in a way using a computer or your phone. Then you printed it out. So that is the output. The hard copy is what is given department. So at the time that the hard copy given to the it's an information to the department. If they want to use it for something else, at the point it could also be. So the information can also be put in a computer for future use. So if you save a copy of the admission letter on your phone, and information on your phone, which you could use later on. So why is a computer so powerful? These are the reasons why we normally call computers to be, say computers are powerful. Ability to perform information processing cycle, amazing speed. If I pull out my calculator right now and tell it to do some computation for me, the moment I put in those values and I press equal to, automatically I get a result. And that's how fast it is. And computers work in that way. We call it powerful because it's able to process information or data at a very high or tremendous speed. And that is so amazing. It is reliable in a sense that it doesn't fail most of the time. You know, if you put in 2 plus 2, hardly will it give you 5. It is very difficult for it to give you an answer of 5 because it has been programmed to give the right answer. So the answers or the information that is given to a computer, the output or the information that we get from a computer is always, if not 100%, most of the time it's very reliable. It is also accurate in terms of accuracy. If you tell it to draw a line, it will not draw a crooked line for you. It is accurate in performing some of its tasks. So the ability to also store huge amount of data and also information. Now, this year, for instance, over 3,000 students were given admission. Now, each one of you, we told you to print a hard copy of your admission form, not your admission letter, admission form, and post it to us. So imagine 3,000 records being posted to us. This is my office. You can imagine the heap of files that you can have in here. So if possibly this is the record of maybe, let's say, 10 students, these are the printouts of 10 students or envelopes of 10 students, and we keep piling them. So you can imagine this is one, let's say this is 1. 10 will probably be like this, 50, so 3,000. It gets to a point in the room, we will have a whole room will be storing unnecessary information, which is the hard copy. So the computer becomes powerful in this way. The same data that we have all those records on the computer, which is stored with a very small size. And that size is just residing something somewhere, if this is the hard disk, if this is the hard disk, the information that we store is probably something for the entire people that had admission this year will be stored. We'll have a space so small on the hard disk. So we're able to store huge data for the use of a computer, and that is a very good reason why we also term it as very powerful. And again, it also has the ability to communicate with other computers. You see where you are. You are using your phone. I'm able to talk to you. You're able to hear me out. Don't you see that to be so powerful? It's mainly because a computer is indeed powerful. And there are certain technologies that goes in there that makes it possible for me to talk, for you to hear me in real time and see what is happening at any point in time. So that is what makes the computer powerful. These are about 5 things we normally say a computer is powerful. So how does a computer know what to do at any point in time? And these are some of them. So in general, I hope to finish this quickly. It must be given a detailed list of instructions, normally termed as a computer program or software. So this use the program or the software itself tells it exactly what to do. So that is how a computer knows what to do. If you want, like the calculator instance I gave you, or maybe if you want to open Microsoft Word or VLC, the moment you double tap it, you've given it an instruction. If you have VLC open on your, the moment you double tap on the VLC, it opens VLC for you to watch a movie. It's because you have given it an instruction. And that instruction is carried out with what we call the computer software. Usually it's an operating system software. And most of the VLC is an application. I'll talk about that. Application software. Those are differences between the software. So a computer is able to know what to do because of what you tell it to do. If you double click, it knows you want to open. If you right click, it knows you want to make a selection. You have a feel of this in the class. So before processing a specific job, the computer program corresponding to that particular job must be stored in memory. By saying this, if you want to watch a movie with VLC, then it means you should be able to have the VLC software installed in memory on the computer for it to be able to process the viewing of the video. So every task that you need to carry out with the computer, there should be a corresponding program that will be able to target that specific job or task that you want to do. So once the program is stored in memory, the computer can start the operation by executing the program instruction one after the other. So generally, that is how the computer knows what to do at any point in time. Now, there are some primary components of the computer. We've already talked about them, but I'm going to reiterate about hits. And this time round, I would want you to now picture it or classify it as a primary component of a computer. So that is the input devices, the processing units, the memory, the output devices, and the storage. So when we talk of input devices, these are devices, of course, that put information into the computer. Processing, CPU is responsible for processing such information that is in there. Memory, and like the hard disks and all of that, and the RAM is able to store those information. The output is being held. Also, the storage also can store it for a longer period of time. Now, so generally, we have the memory residing in here. By memory, we mean to say, usually is the random access memory, the RAM. Now, for a computer to function, it should have what we call memory. It should be able to, the memory is responsible for the coordination of all these components. So the memory resides at the middle of these components. And because of that, it's able to communicate with all these components. Now, the input device now sends information to a computer and is stored in memory based on the information that is sent. And that task that you want it to do based on the input device is sent either to the CPU for control units or for arithmetic logic units. I'll explain this one as well. And when the processing is done, it's sent back to memory. Then it's now find out, okay, do you want to store that information, that's the task that you give us on storage devices, or you want to push it out to an output device? If you want to store it on a storage device, then you store it. At any point in time, you can use your input device to also pull out that information from the storage device. So we brought to the memory, and now you can do certain computation to it, or you can output it out. Now, still on the uses of computers, normally we say PC. PC stands for personal computer, and these are the common uses of computers at home. We commonly use computers in the house to do these. So at your hostels, those that have computers, you normally use it to play games. Some of you might be working offline, so use it to working from home. There are times I work from home. There are times when I'm home and there are issues with maybe one or some few of the servers, or if I want to do some installation, I'm able to, whilst home, I'm able to remote into the computers that are at the ICT unit. I'm sorry, I'm the webmaster for the university. So most times, I sometimes work alongside with the ICT units to do some few other things. So there are times I'm home over the weekend, I'm able to access the computers at the ICT units to do some few other things. And again, for instance, I'm in my office. If there is something critical that needs to be done, maybe, let's say on a VLE, I don't need to walk straight to the VLE, to the ICT units to be able to do that, to work on the server. By remote desktop or remote access, I can be able to, I will be able to be at home or even in the office now and call on that particular server. And the interface will look exactly like how I'm using my computer. So I have access to it to be able to do other things. We can use this for banking. There are times those that you do online transactions, you're able to buy things online using their computers that resides in their homes or their PCs that is being used at home. Connecting to the web, we always use to connect to the internet, Facebooking, Instagram, Twitter, LinkedIn, and all of that. So these are common uses of the computer, which we term as the PC or the home use, that computers can be used at home. Now, there are other uses that we will talk about. The first one is the stock control. So for instance, let me read what is there here so I can explain. The stock control is ideal for automation, and is in many companies, it's now completely computerized. So for instance, if I have a supermarket, like those that have gone to any of the big supermarkets, we have something we call point of sale, which is the POS. What happens is, at the supermarkets, if they are to stock maybe 100 milk tins, they input all those details in the computer. So the moment one person pick maybe a milk tin, if he picks, let's say 5 milk tins, and he gets to the counter, and the teller, whoever is at the counter, now enters in 5 milk tins, then it means automatically there is an automatic deduction of 5 from the 100 milk tins that's in the shelf. So it has reduced to 95. If you have more people taking in more of the tins, the system could be set in such a way that the moment we have about, let's say, 5 milk tins in the shelf inside the supermarket, it should alert the administrator or whoever is in charge or the manager to restock or to bring back more milk tins. So the computer can be used to do some of these things. And most of the time, this thing go hand in hand with the point of sale, which is the POS, to help track each of the items that are in stock at any point in time. So the stock control system keeps track of the number of items in stock and can automatically order placement items when required. In our part of the world, the ordering might not work, but outside it will work, mainly because, like Amazon, for instance, if they have these a quantity, in there, the system can be scheduled in a way that the moment you have about maybe 5 in stock, an email is probably sent or an order trigger is sent to the manufacturer to bring us new set of, maybe if it's a tin or set of those equipments. So you don't need to call the manufacturer to bring in new stock, new of those products, new stuff. But automatically the system can do that. That's why a computer can be used for that. Payrolls. So in most large organizations, the accounts are maintained by computer system. So now, for some time, we were receiving our payroll, our pay slip with, by hard copy. Now, the server has now been configured in a way that automatically at the end of the month, just a button is pressed and everybody gets the pay slip. And it is organized in a way. And this helps to reduce the repetitive nature of the accounts computer system, within a computer system. When it deals with money, we don't need to add zeros and, make mistakes. So by the use of a computer in the area of the payroll, it becomes difficult for minor mistakes to be made. If it is by manual, there's a likelihood whoever is preparing the pay slip make a mistake. But when it's being used by the computer, it's a little difficult. Again, computer in our daily lives, that is what we normally use a computer for. Accounts, games, educational purposes, online banking, smart cards, supermarket, working from home, which is teleworking, and the internet, and so on and so on. Now, there are types of computers that I want to talk about. We have about 20 minutes. I will wrap up quickly. So when we talk of the types of computers, the most basic difference between a computer system should be related to the size and its use. So anytime you hear of the type of computers or types of computers, have this in mind that when I talk of the type, we want to find out the size and what that computer is going to use. So these are two things: the size and its usage. Helps us to know that each computer is. So the most basic difference between computer system is the size and the use. So based on the size and based on what it's used for, we can now classify it as type 1, type 2, type 3, or type 4. Mobile devices or computer devices refers to smaller and mobile. Now I was talking about the PDAs. I don't know if it still exists. Those times, PDAs were meant for personal digital assistants. So they were assisting people to do personal stuff by scheduling meetings and other things. We have smartphones, like what we have smartphones. We have wearable computers, and the smartwatches, smart cards, and so on and so forth. These are categories that will fall in the mobile devices or computer devices, computing devices. These are just some basic terms that we normally classify computers, or we talk about the types as we move along. Now, when we say a workstation or a microcomputer, they are the smallest computers. Most of the time, they are the desktop and the personal computers that you have. We say it's inexpensive. That's just a little relative anyway. So in a computer lab, the computers that you see there, they are microcomputers, or they are workstations. We can call them as workstations. So a workstation is a powerful single user computer that runs intensive scientific and also engineering application, such as engineering design, medical imaging. It depends. There are some workstations that are robust enough to handle some of these applications. But generally, the ones that we have at the lab, we normally will term them as workstations. Now, when we talk about the type of computer, I said there are two things that you should have in mind. It should be based on the size and based on its use. So in an exam, if you are asked, what are the types of computers? There are four main types of computers. And these types are based on the usage and also the size. Now we have the microcomputer, we have the mini computer, we have the mainframe computer, and we have the supercomputer. And from how it has been displayed in here, in terms of size, the microcomputer is smaller than the mini computer. The mini computer is smaller than the mainframe computer, and the mainframe computer is smaller than the supercomputer. That is in terms of size. Excuse me. So now let's talk about each one of them. Microcomputer. They are the smallest computers. So most times, whenever we talk about microcomputer, we mean the desktop or personal computers or workstations. Sometimes we classify the thin client system also as an example of a microcomputer. I'll show you an example of the thin client system. Your laptop, those that have laptops and notebooks, laptops, they are just about the same. They fall under the microcomputer because they are the smallest type of computers that are available. In terms of cost, these are inexpensive and are used by one person at a time. You recall, I was saying, anytime we talk about the type of computer, it is based on the size and it is based on the usage. So if it is being used by one person, for this particular one, it is a microcomputer. And by cost, we mean to say the microcomputers are inexpensive. Somebody will say, hey, inexpensive. And now if you buy a laptop is around 4,000 Ghana cedis. And I'm saying it's inexpensive. Well, I say it's inexpensive mainly because when you compare the cost of this to all of these, this is not expensive. This is expensive than this. This is expensive than this. This is expensive than this. That is how it works. So comparing all four, the microcomputer is not expensive. So that makes it inexpensive. That is what I mean by it's being inexpensive. Workstations are powerful single-user computers, as I've said. They can help do the computation of stuff and also run some engineering design. So mostly microcomputers are used by students and also reporters or lecturers, individuals. So most of the computers that we normally use ourselves are the microcomputers. So in terms of use and who uses it, and size, the microcomputer is smallest, and most times it's being used by one person at a time. And it's mostly used by individuals like students, reporters, journalists, lawyers, lecturers, individual people use microcomputers. And this is how microcomputers look like. These are different versions or variants of microcomputers. You can see the desktop computer is an example of a microcomputer. That is what you see in here. So this is a microcomputer, excuse me. There's a laptop. There's also a microcomputer. Netbook, laptop, netbook, they are all about the same. You can use them interchangeably. Palm top. Now, I don't think palm top really exists, I can say. Because of mobile phones, palm top and these small devices are not really being produced now. So these are examples of micro computers, and it's being used by individuals. If you are able to carry it yourself under your armpits, or you're able to put it on your table and use daily, it's usually a microcomputer. I talked about the thin client system. This is how the thin client system also looks. Now, the thin client system works this way. There is, when we talk about personal computers, we said it was made of system units, a monitor, a keyboard, and a mouse. And sometimes we have other peripherals, or we have the speaker and the microphone all being patched. Now, with this one, with the thin client system, we have just one computer, one system unit, with so many monitor, keyboard, and mouse, all connected in a way to the system unit. And most times when you go to a cafe, most cafes have the thin client system. And this makes it a little expensive. Instead of having to buy a system unit for each one of these monitors, which is expensive, you can have just one system unit, which is powerful enough, which is robust enough to allow all these computers to connect to it. So that is how the thin client computer works. So with that, there's only one system unit, and all these and each of these are connected in a way to this. Now, in real life, this is how it looks like. You can see such computers have the monitor. It has this hub, which will take the mouse and network, that where the keyboard is. You can see this person has the keyboard. I have a system unit. And this is the device. The mouse and the keyboard are all connected to. So each of these will have this device, more like a hub. This device connects to the system unit, which is the system unit. And the device I showed you, this is it. It's the one. So that is how the device, that is what it is. So it connects all these monitor, keyboard, and mouse to the system unit. And if you can see, the fact that they are connected together doesn't mean you can't use it simultaneously. So now this person has opened one program, another person has opened Firefox, another person has opened a different program. And all the programs that have been opened in here are all installed on the system unit in here. So this computer should be powerful enough to serve all these clients. So that is how the thin client computer or thin client system works. All right, so uses of a computer. These are the basic uses of a computer. Yes, usually with a thin client, Edmond, sorry, a message. Usually with a thin client, they are networked together in a way. So they probably use a network cable to get all those connected together. Like, see, the device has a port for the network, so all these ones will be connected together, and they can talk to the system units in here. So that's how the connection is. It is a little less expensive compared to having to buy a complete computer for each of them, that makes it so expensive. Now, in terms of the uses of a computer, in fact, all the types of uses, all the uses of a computer that you can think of for playing games and doing all of that can be grouped into these 5 main steps. These 5 main uses: word processing, home entertainment, home banking, printing, surfing the internet. So these are the main uses of a computer. Each one of them that you can think of can either fall under a category in here. So still on the, so that is about the microcomputer. Let me hit on the mini computer. And in fact, let me end here with the mini computer. We have spent almost 30 minutes. I'm going to save this video. I'll put it on the VLE. Please watch it. And class, I would be happy again if by tomorrow, you can get me another lecture on the VLE like this, so I can complete this. I'll be very happy, so that possibly from next week, we can start with the practicals. So can you help me get a VLE session tomorrow? If you are free, if you get a time, just class rep, just alert me and let me know if I'm available. Let's hold another VLE session to finish up this particular slide. Thank you very much. Those of you that have questions on the VLE, I have a place for forum. You can put in your question in there, and any member, any person in the class, or any student in the class who answers some of the questions, I'll have a mark for them. So you can create, there's a forum portion, you can add the question in there, and when I do see it too, I will also answer. But I would love it if students are able to answer such questions. I have marks for students who are active on the VLE. So if you have a question from whatever I've said up till now, you can put it there. All right. Thank you very much and have a good morning. I'm going to stop the sharing and I'm going to stop the recording. I think Desi has a hands up. Unfortunately, I didn't see you early.